We are seeing many people struggling to achieve gauge accuracy when applying thread mills. Therefore, we have decided to make this video. In a few simple steps, we will show you how to produce a thread that is accurate to gauge from the very first cut. Disclaimer: this works only for the T2710, 11, 12 and 13 thread mills. For demonstration purposes, we use our T2710 in the dimension M20. And first of all, we have to assemble the tool. If you are machining a blind hole, don't forget to remove the coolant screw. This will give you through coolant, which is perfect for chip evacuation. And now we can put the tool on the presetting machine to measure the cutting diameter. Make sure to measure all cutting edges to find the largest, because this one will cut the size. Be careful here, some machines work with the radius and some with the diameter. As our machine works with the radius, we have selected the radius as output. Now we are ready to load our tool into the machine. The CNC code we have created with Walter GPS, which is our navigation system for machining. It is available for free on our website, walter-tools.com, but you can also use any CAM software or built-in machine cycle to create the CNC code. Now we have to enter our measured tool radius into the tool table of the machine. But to get a thread that is accurate to gauge, we need to consider the radius correction values, which we see in the header of the CNC program that we have created with Walter GPS. There are two values to choose from, one for the lower end of tolerance and one for mid of tolerance. The value for lower end of tolerance you use, for example, when you run a tool for the very first time to have an allowance in case that you need to remachine the thread. However, we have promised that we will reach accuracy to gauge right away, and therefore we use the value for mid of tolerance. We simply subtract the radius correction value, in this case 0.2 mm, from our measured radius, and here we go. Alright, let's see if we have kept our promise. The go gauge runs fine, and the no-go gauge doesn't go in. And that's exactly what we wanted to achieve. But some of you might wonder, why do we need radius correction values? Well, the reason is simple. On the presetting machine, we have measured the outer diameter. But accuracy to gauge is not defined by the outer diameter, it is defined by the pitch diameter. And the pitch diameter we cannot measure on the presetting machine. We only can calculate it based on our measured value. Since we know the edge radius of our insert, and since we know which pitch to machine, it is a simple mathematical task to calculate the pitch diameter. But you don't have to worry about the math. You can use the radius correction from Walter GPS, or from this table which we have in our catalog, and which is also linked below. One final expert tip: if you don't want to enter the radius correction values manually each time, you can include them in the CNC code right away. If you use a CAM software, for example, just double the radius correction value and add it to the diameter of the thread. In our example, we have machined an M20 thread and the radius correction value was 0.2 mm. So if you program a thread with 20.4 mm diameter, it will be spot on each time. Let's recap the steps. Measure the tool on the presetting machine, subtract the radius correction value, machine a thread that is accurate to gauge. That's it. 3 simple steps. Thanks for watching.